Problem 1 is a review of the chain rule. So we're going to run through these and make sure that we're all up to speed on how to properly do the chain rule in a problem. So let's remember that chain rule is the derivative of the outside function times the derivative of the inside function. So for this first problem, we have a bunch of stuff raised to the 5. So the derivative of the outside function is just going to be 5, right, times that stuff raised to the 4th. So then we just copy x cubed minus 7x down. Now we need to come back and take the derivative of what's inside the parentheses, and that's just going to be 3x squared minus 7. So derivative of the outside times derivative of the inside. The second one, same thing. We have an expression being raised to the 5th. So the derivative of the outside is going to be 5 times that to the 4th. So then we just leave this alone. And then the derivative of what's inside is negative 2x. For the last one, right, here we don't have an expression inside, right? We just have a function raised to the 5th. So just like we did in the previous two problems, right, the derivative involving the chain rule is just 5 times that raised to the 4th. So in this case, instead of an expression, we have f of x. And then the derivative of the inside is just f prime of x, right? We don't know what it is, but we know we're just supposed to take the derivative of whatever this function happens to be. So part B says, well, now let's take a derivative of y to the 5th. So y to the 5th is actually the exact same thing as here, because we actually write expressions y equals f of x. So when you're plotting a graph, you plug numbers into the function, and then the values that come out are the y coordinates. So y is actually taking the placeholder of a function of x. So we have to treat every y we see in a problem as if it's a chain rule. So just like we did in the previous part, it's going to be 5y to the 4th, because that's the derivative of the outside, but then we need to multiply it by the derivative of y itself. So we usually write this as dy dx, so derivative of y with respect to x. So y is just has this is some invisible function of x. We don't know what the expression is, but we know it is an expression of x and has some hidden x's inside. So we have to tack on this little dy dx every time we take a derivative with y.